Alright folks, in this video we're going to continue our discussion of topic number 3, types of reactions. We're going to focus on precipitation reactions, and then we'll talk about how we write ionic equations, and then we'll take a look at what gas evolution reaction is. Before we talk about precipitation reaction, let's take a quick review about the solubility of ionic compounds. Well, again, this table from your textbook has two parts. Top part is about soluble ionic compound with the exceptions. The bottom part is about insoluble ionic compound with exceptions. As I suggested before, you can just remember the top part of this table, and then anything, in other words, if you remember those soluble salts with their exceptions, then anything outside this top part will be insoluble. Okay, let's just do a quick practice, like iron. Iron hydroxide. Okay, well, if you take a look at the formula, cation is iron, the anion is hydroxide. Well, iron cation is not in this top part. Hydroxide is not one of the exceptions in this top part. Therefore, it's outside this top part. It's insoluble. Okay, it's insoluble in this case. All right. Okay. Based on this, let's take a look at these two reactions. The two reactions, one gives you a precipitate, the other one, no reaction. Well, let's take a look at this precipitation reaction first. Well, precipitation reaction, according to the name of this term, you will see that, okay, if a reaction can generate a precipitate, then we call it precipitation reaction. For this particular case, you have potassium iodide react with lead nitrate and generates potassium nitrate and lead iodide. Okay, so if you write the full equation here, so that's going to be 2 equivalent of the potassium iodide. We write AQ as the state, which means that this is soluble in water. Remember, all of the potassium salts, they are soluble. Okay, so we use AQ to label the state. And then lead nitrate. Okay, again, it's AQ. It's because all of the nitrate salts, they are soluble. Therefore, AQ would be the state. Now, generate 2 products. Okay, so it's going to be 2 potassium nitrate. Of course, this is going to be AQ because potassium salts are soluble, nitrate salts, all of them are soluble, so apparently potassium nitrate will be soluble. Now, the other product would be lead iodide, and this is insoluble. Insoluble. When you have insoluble product, that means it will precipitate out from the solution, generate solid. So we use S to represent the state of this precipitation. Okay, so this is the full reaction. Now let's take a look at the ionic equation, or a complete ionic equation. What does that mean? It means you are going to write the ions that comes from those ionic compounds and their products, and then take a look at how they react with each other, how different ions combine with each other to form the products. Okay, so let's take a look. The 2 equivalents of potassium iodide will give you 2 potassium cation in aqueous solution and 2 iodide anion in aqueous solution. So these are the 2 ions from the first reactant. Now the second reactant, it will generate 2 ions also. The first one is lead 2+. It is soluble. Okay. Well, when you dissociate the ionic compound, the state of the ionic compound will be the same as the ani. Okay, if the ionic compound can dissociate or soluble. All right. Now plus nitrate, 2 nitrate, AQ. Okay. Remember the 2 comes from 2 here. Okay. Now these are the 4 ions dissociate from the 2 reactants. Now 2 products. This is soluble. Therefore, it will give you 2 potassium cation, AQ, and 2 nitrate. It is still AQ. And now the second product, lead iodide, it's solid, means it's not going to dissociate, so cannot give you any ions. Well, so when you write the ionic equation here, lead iodide remain as solid, no dissociation. Okay. Now this is a complete ionic equation. You just write all of the ions that can be dissociated from those ionic compounds, those soluble ionic compounds. If you have salts, if you have precipitation, then you just write the precipitation. It will remain unchanged. Okay. Now, this is a complete ionic equation. Now, if you double check the 2 sides, looks like the 2 sides share something in common. Okay. The 2 sides means the reactant side and the product side. Now, on the reactant side, you have 2 equivalent of potassium in aqueous solution. On the product side, you also have 2 equivalent of potassium cation in aqueous solution. So you have the same species on 2 sides, so they can be canceled. Okay, they can be canceled. Now, I'll use the red color. Okay, just want you to see that clearly. They can be canceled. If you have identical items on 2 sides, they can be canceled. Now, another thing that we can cancel is the nitrate. You have 2 nitrates on the reactant side, 2 nitrates on the product side. So again, these 2 will be canceled. And if you check the other species, you cannot cancel any items anymore. All right, so you write this down to get net ionic equation. Okay. All right. So this is net ionic equation. And this is a complete ionic equation. Okay, so what's the difference between the complete ionic equation and net ionic equation? Well, as you notice that for net ionic equation, you are going to just show those ions that can form precipitates. Okay, or later on, after we discuss some other types of chemical reactions, you will see that net ionic equation means those ions involved in the formation of either solid or gas or pure liquid. All right, for this particular case, for precipitation reaction, only those ions involved in the formation of the precipitation will be written in the net ionic equation. For a complete ionic equation, no matter whether those ions can be canceled or not, you show them all. Okay, you show all of them, and so this is the complete ionic equation and net ionic equation. Okay, now let's take a look at this example. Well, this example is between potassium iodide and sodium chloride. Well, the conclusion from this reaction is no reaction. What do I mean by that? Well, don't you get this potassium iodide react with sodium chloride in aqueous solution, you know, if you exchange the cations and anions, are you supposed to get sodium iodide and potassium chloride? Well, it looks like this is going to be the case for this reaction, right? But why do we say it's no reaction? Well, let's write the complete ionic equation and the net ionic equation, and then it will tell you. For net ionic equation, okay, let me use a black color to write the first one here, complete ionic equation. But by the way, if this one can happen, this reaction has been balanced. Okay, it's 1 to 1 to 1 to 1 ratio. Now, potassium iodide, it will give you potassium cation and iodide Ni. Okay, for sodium chloride, it will give you sodium cation and chloride anion. Generates, well, the two products. If you can get these two products, you will get one equivalent of sodium cation plus one equivalent of iodide and plus one equivalent of potassium aqueous and chloride. Okay, so this is the complete ionic equation based on this chemical reaction. Now, if you double check those species that are shared in common on the two sides, or double check the species that are identical on the two sides. Well, you have potassium here, iodide here, sodium cation, chloride. Well, it looks like that for the ions that you can cancel, potassium can be canceled. They are identical. Iodide can be canceled. They are identical. Sodium cation can be canceled. Chloride can be canceled. So you can cancel all four ions on both sides. In other words, for net ionic equation, there's nothing left. Okay? So that's why we said that no reaction. Okay, there would be no reaction because there's even if you can exchange those two cations and anions, but in aqueous solution, they are going to dissociate to give you exactly the same ions on two sides. So there's no driving force for this reaction to proceed and generate these two products in solution. Okay, now by looking at those two examples, you can see that net ionic equation can make the reaction simpler and easier for us to identify what the product is, or to identify whether the reaction can happen or not. Okay, so this is the precipitation reaction and ionic equations. Now let's take a look at the gas evolution reactions. Well, gas evolution reaction, based on the name, a reaction that can generate a gas, then that's going to be gas evolution reaction. Okay, now you have the sodium bicarbonate reacted with hydrochloric acid. It generates three products: water, sodium chloride, and carbon dioxide. Carbon dioxide is a gas. You can see bubbles from this reaction. Therefore, this is a gas evolution reaction. Since we've already discussed complete ionic equation and net ionic equation, let's try what the complete ionic equation and net ionic equation of this reaction look like. Okay, let me write the full reaction first. Okay, sodium bicarbonate. This is soluble. All of the sodium salts are soluble. React with hydrochloric acid in aqueous solution. It generates water. It's a pure liquid. We use L to represent the state. Sodium chloride, it's aqueous solution, and plus carbon dioxide. Okay, now let's write the complete ionic equation. Remember, complete ionic equation, will have all of the ions that can dissociate from those ionic compounds, okay, or electrolytes. Okay, so for the first one here, apparently it will give us complete ionic equation. It will give us sodium cation and bicarbonate, HCO3 minus in aqueous, and proton. This is the HCl, AQ. Okay, so we have 4 ions. These are from sodium bicarbonate. These are from HCl. Now, products. Apparently, water cannot dissociate. It's a covalent compound. It's non-electrolyte. Okay, so we write that as liquid as itself. Okay, all right. Now, the second product, sodium chloride. Well, this is a ionic compound. It will give you sodium cation and chloride anion. Now, the third product, carbon dioxide. Apparently, this is going to be non-electrolyte, covalent compound. It's gas. It's not going to dissociate to give you ions, right? So, in the complete ionic equation, it remains unchanged. All right, so this is a complete ionic equation. Now let's see what kind of ions can be canceled on two sides. Well, you have, let me use different color. Well, you have sodium can be canceled, right? Identical ions. Chloride can be canceled. And then these are the only ions that can be canceled. So therefore, for net ionic equation, it will be bicarbonate plus H plus, okay, generate water and CO2. Okay, so you can see that net ionic equation only shows those critical species that can react with each other to generate either precipitate, S, or pure liquid, or gas. Okay. All right. I hope those examples can demonstrate how we write the complete reaction equation, complete ionic equation, and the net ionic equation. Okay. We'll do more practice when you come back to class.